Welcome to Set Theory 101. This is part 1 called Set Definition. I want to start off with a definition of a set. A set is an unordered collection of objects. An unordered collection of objects. These objects usually take the form of lowercase letters, such as X, Y, and Z. And sets are commonly denoted by capital letters. These capital letters, they can be like capital A, capital B, capital C, and so on. Set inclusion. Let's talk about that. When we want to say X is a member of a set, what we do is we write the element first, and we put the symbol belongs to. So what this means is X is a member of set A. X is a member of set A. You could also say X belongs to set A. That would be the same thing. When we're talking about set exclusion, we basically mean the opposite. So instead of saying X is a member of set A, we say X is not a member of set A. X is not a member of set A. Alright, so you see that the difference between inclusion and exclusion is X is included in set A and X is not included in set A. Now let's talk about set notation. When we talk about explicit set notation, that means we list all the members of a set explicitly. So this is going to list out all the members of a set. So let's see what it looks like in an example. Let's say set A is equal to the set containing the numbers X, Y, and Z. This is explicit because all the members of the set are listed inside of the set. We can say A is the set containing members X, Y, and Z. Another way we can write that is if we wanted to use symbols, we could say X, Y, and Z are members of set A. We could also say, if we have an element that's not in the set, like let's say P is not in set A, because we can't find P in set A. A is the set that only contains the members X, Y, and Z. So this is called explicit set notation. All it does is it lists all the members of the set. Another way we can write a set is by set builder notation. So let's talk about that. Set builder notation. What this does is it builds the set. What it's doing is it's listing all the members of a set. But it's going to do it implicitly instead of explicitly. And it's always done according to some property. According to some property. So let's see what that looks like. We could say A is the set of all members X that satisfies the property P of X. Another way we can write it is A is the set of all members X according to some property P of X. What you'll notice is the only difference between these two notations is we have a colon here, and over here we just have a slash. The way we would say this in words is A is the set of all X such that the property P of X holds. Let's look at an example. Hopefully this will illustrate what I'm talking about. Let's say A is the set of all X, where X is an integer, and X has to be greater than 2. So A is going to be the set of all X that satisfies the property X is an integer and X is greater than 2. So what would this set look like? Let's see if we can write it out. So A is going to be a set. It's going to contain integers, because remember, X has to be an integer, and X has to be greater than 2. So the first integer that's bigger than 2 would be 3. 4 would also be greater than 2. 5 would also be greater than 2. And we can keep on going like this. So we know that we can write a set in set builder notation, but we can also write a set explicitly, naming all the members of the set.